we're going to learn how to find derivatives of the natural and common logarithmic functions and walk through some examples. The derivative of the natural logarithm, ln u, is equal to 1 over u. U is just what's inside the natural log, times du dx. To find the derivative of the general logarithmic function, we need to use the change of base formula, which I've listed right here. It tells us that the log base b of x is just the natural log of x divided by the natural log of b. The derivative of a general logarithm, log base b of u, is then 1 over u times ln b times du dx. So it's the same thing as the derivative of the natural log, except you have to divide by natural log b. Let's now walk through 4 examples, and in each example, we are going to differentiate the given function. Here's our first function. We are going to differentiate the natural log of sine of x. Our derivative we can write as f prime of x, and the derivative of the natural log of sine x is 1 over u, and u is sine x, so we have 1 over sine x, times the derivative of sine x, which is cosine x. This gives us cosine x over sine x, so our answer is cotangent x. Let's now look at our second example. We're going to differentiate the function x times the natural log of x squared plus 1. Notice that f of x contains 2 functions, x and the natural log of x squared plus 1. So to take the derivative, we're going to use the product rule. This gives us f prime of x is the first, which is x, times the derivative of our second function. The derivative of the natural log of x squared plus 1 is the derivative of x squared plus 1 on top, which is 2x, and then we just put the x squared plus 1 in the denominator. And then we have our second function, natural log x squared plus 1, times the derivative of our first. The derivative of x is just 1. So we can write our answer as 2x squared, all divided by x squared plus 1, plus natural log x squared plus 1. And we'll go ahead and we'll highlight that answer. Let's now look at our third example. We are going to differentiate the function f of x is equal to the natural log of 3 divided by x. Because the x in this function is in the denominator, I'm going to start by rewriting our function as f of x is equal to the natural log 3x to the minus 1. That's just going to make it easier to take the derivative. Our derivative f prime of x then is the derivative of what's inside, so that is minus 3x to the minus 2, all divided by what's inside, which is 3x to the minus 1. The 3's are going to cancel, and our top term I'm going to write as minus 1 over x squared, and then our bottom term is 1 over x. To simplify this, we can just multiply the top and the bottom by x, so we get an answer of minus 1 over x. Let's now look at example 4. This one has a common log. We are going to take the derivative of log base 5 of 2x squared plus 7. Our derivative, f prime of x, is the derivative of what's inside. The derivative of 2x squared plus 7 is 4x, all divided by what's inside, which is 2x squared plus 7, times natural log of 5. When you have a common log, you always have to divide by the natural log of the base. And we actually don't need to simplify that anymore, so that is our final answer.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.